where does real-timeness matter? I'm going to take one example, personalization of offers. And I'm going to take you through essentially levels of sophistication. And we're going to start with the most basic level. You know, when you think about personalization, you can think about, you know, the most basic capability the company can have is that from time to time, they're going to send every customer a coupon, right? And that coupon is going to encourage some kind of a buying behavior. And what is it based on? It's based on basically demographics, right? Like every teenager from, you know, 14 to 17 living in this zip code, you know, with this level of income, if it's a girl, is going to get, you know, offered to buy whatever lipstick before the prom, right? That's not a real-time problem because you have all this historic data that leads to segmentation. And you had all the time in the world to collect that data, and you had all the time in the world to analyze it, and it's very crude. It's personalized in the sense that 21-year-old and 17-year-old will probably get different coupons, but all 17-year-olds in the same zip code are going to get the same offer. Very basic level of personalization. Now, you can try to be more sophisticated. Now, you can tie a promotion or event or an offer to some very specific individual characteristics. For example, on a birthday, a person can receive a coupon that is offering some discount of the item that we know that person wanted to buy before. Maybe it was on a shopping cart, maybe it was looking at that product online, right? Now, this is much more personalized. So you should expect much higher conversion, right, and better margins on this kind of sales. This is also not a real-time problem. Because, hey, birthdays happens once a year, and you had all this time to collect data. However, it's a much harder problem for companies to solve, because it requires what's called 360-degree view of the customer. You need to be able in one place, load their profile, load their shopping history, load their order history, load their click streams, right? This is, by the way, today the driver for a lot of data lake projects. A lot of the reasons why companies want to build one data lake and then load all the data from all the line of business systems is because they want to be able to correlate things like profile, shopping history, and other things, and tie it to a personalized offer. Not a real time problem, but it's a data accessibility problem. Now let's introduce situational context. Let's say I'm a customer. Let's say I'm in the actual physical retail store. I'm shopping right now, and I just spent an hour looking at stuff. And I took 20 items. I'm a girl. I went to the back end, I tried them all, and I'm walking out with 8 of them, right? And I'm going to the register, and this 8 I clearly like. But then, you know, they scan it, and it's too expensive. I can't afford to pay for 8. I'm going to buy 5. So I'm going to buy these 5, and I'm going to not buy these 3. Now, if you have a really sophisticated systems, you can actually incent my behavior right now to buy the other 3. How? Well, you can give me a coupon for 25% off for these 3 things that you know I'm holding in my hands and want to buy, but I decided not to. You can offer me a bundled offering. Buy all 8 and pay this price, right? You can do a lot of other sophisticated things. But you cannot do that without real time because your offer depends on what I did 5 minutes ago or less, right? Now, that's powerful. You're going to get much bigger conversion here. But you need to be able to react to things that didn't happen last night, that happened 3 minutes ago. And finally, level 4 are the things that you are starting to exploit in real time, information about supply chain, inventory, weather patterns. My favorite example here is that imagine on the first rainy day of the season. In California, it's very binary, right? I live in the Bay Area. So we have a drought in the fall, in the summertime, and then we come in November, and first huge rain comes. And if you're in San Francisco, by 5 p.m., you're freezing. And you're thinking, oh my God, I have to exit the building and I have to get drenched. Imagine that, you know, you get a coupon or you get an email that says, hey, you know, sorry for the bad weather in San Francisco, but how about we brighten your evening? in 30 minutes, when you're ready to leave the building, we're going to deliver umbrella and hot cocoa to your doors. If you think about power of something like that, and you think about what kind of systems is required at the back end, not only they're real-time systems, but they're based on things like demand surges, product availability, competitive pricing, weather patterns. And essentially, you get metrics, something like that. As that to operate at the lower levels, they're suited for machine learning that happens offline. But to do this really sophisticated, interesting correlation analysis and custom offers, you require real-time processing. And then sometimes, you can get away with only segmented data. But really, really powerful offerings require you to collect all the data from different systems, essentially under one roof, have models that can process and correlate between these things, demand, weather patterns, product availability, preferences, user profiles, and do it in real time. So value kind of grows up that way. Does that make sense? Now, these are what I consider top 6 business drivers of real-time applications in retail. This is what customers are paying big money to solve today. By today, in 2017, 2018, right? We see a lot of these things going into 2018 in big ticket items. Kind of the baseline thing is things like alerts. Fraud detection is a classic one. Anytime you have some kind of unusual pattern, or you're going outside of the expected range, you want to get an alert. If your inventory is running low in a certain store, you want to get an alert, right? If your supply chain is getting backed up, you want to get an alert. If you don't have enough manpower in the store, you want to get an alert. So the basic kind of fundamental use case for these real-time systems is generating alerts when you see some kind of detecting unusual pattern. Big driver for a lot of money invested in supply chain is what's called intelligent sourcing. Intelligent sourcing is a big problem. Amazon is brilliant at this, everybody else sucks, and there's a lot of margin drain that companies now want to solve. If you are Macy's or Kohl's or Gap or whatever, you probably have close to 1,000 stores. You also have your online site, and lots of customers are buying products online. You also have a few distribution centers, but usually not that many, and they're regional. So more and more of them want to treat their stores as distribution centers. And when the orders come in, they want to route the order to the store, pack the items that somebody bought from the store, and ship from the store. So essentially, your store becomes your distribution channels or shipping centers, and now you have thousands of them. Now, if you do this smartly, or you do it stupidly, affects your margins in a dramatic way. If you can allocate the right orders to the right location and source all the orders in the right way, and your inventory doesn't drop below the levels that you want, you're going to be making money. And if you don't do it right, you're not. And it's a very complex mathematical problem. So applying various machine learning techniques to optimize your sorting decision, essentially determine which orders to source from what store, so that you manage both SLAs and shipment costs, is actually a massive operations research problem these days. Next is dynamic inventory. Dynamic inventory essentially tells them how much items to keep in stock in every location for every item at all time. Today, it's all very crude. It's driven by some arbitrary business rules. It tends to be static. Sometimes business analysts say how much inventory to have at hand. Usually it's not really adapted to the demand curve. And again, there is a tremendous margin loss for getting it wrong. On one hand, you're always either stuck with inventory that doesn't move, and then you need to discount it, or you didn't stack enough hot items, and then you're losing sales. Everybody wants to apply mathematics to be able to track demand in real time and come up with mathematical models that actually tell you how much inventory you should have in every store at every point in time. Dynamic pricing. It's amazing how complicated the thing called price for an item is. You can look at it as a very crude way and say, well, it's a thing, right? It's a number. This product costs $3.99 and this product costs $9.99. Ideally, how much something costs depends on how much availability is on the product, how much demand is on the product, how much people are willing to pay for it right now, how much this person is willing to pay for it right now, how much my competition is charging for it right now. Plus, there is coupons, plus there is specialized offers, right? Plus. So if you think about it, if you can solve the problem of dynamic optimization, of always putting the price that is the optimal price that that person is willing to pay to buy that item right now, right? Holy grail.
Impulse.
Yeah, basically motivating impulse or whatnot, but also computing, it's a supply and demand curve, right? How much am I willing to discount that item to still make money and motivate that person's behavior of buying? So anyway, determining the right price based on all these other custom things, dynamic things, is a very big opportunity. And people, again, wanted to do that for a long time, did not have the tools. Now, finally, we're getting to the point where we can begin building systems that can make dynamic pricing work. We already talked about personalized offers. The more you can incent somebody's behavior of buying product right now, and it doesn't have to be an item, right? It could be, going to the doctor or going to the movies or going to the concerts or, buying travel packages, same kind of deal, or airline tickets. The better you are. And believe it or not, probably the hottest topic in personalization is search. Now, this is fascinating. It's fascinating for us because as a company, we've actually been working with search technologies for a very long time. We have a lot of expertise on how to build search engines, particularly retail search engines. We build search engines for Macy's.com, and Kohl's.com, and JCPenney, and a bunch of other companies. And until recently, if I type a search query, I'm looking for the evening dress by Calvin Klein. And another person types exactly same search query. I'm looking for black dress by Calvin Klein. We're going to get exactly the same results, right? But we are likely looking for very different things. Because what I want for my dress and what another person, half my age, my daughter, wants for her dress are two very different things. So we can actually take the same query, incorporate what we know about a person, and come up with completely different answers. It could be a different set of products. It could be different ranking, right, of the products. And search is such a powerful way in which consumers find anything that actually personalizing search has tremendous potential.